Hello, thanks for joining. I'm Travis Whitfield,
And I'm Kaylee Jorgensen.
and we're part of Morningstar Engineering along with Amy Carmelini, Jessica Cooper, Madeline Tennant, and Nikki Voss. Our project was wastewater treatment plant additions for the North Davis Sewer District. The North Davis Sewer District wastewater treatment plant services wastewater from Syracuse, Utah. Due to more stringent nutrient discharge requirements going into effect in 2020, the plant must upgrade their treatment system in order to reduce total phosphorus and total inorganic nitrogen concentrations in their effluent. For this project, we considered 9 different alternatives, which we will outline later. For each alternative, we projected population, flow, and nutrient loading to 2050, which you can see here in figure 2. The first alternative we considered was a do nothing. We found this infeasible because this would make the plant in violation of their discharge permit and would make them liable to a daily fine. The second alternative we considered was a no discharge alternative, which involves land application of the effluent. This was not chosen due to unstable soil conditions and a high water table. Discharge into Farmington Bay, which you can see here in figure 1A, would require the removal of nitrogen to less than 10 milligrams per liter, as well as phosphorus removal. The first alternative we looked into for nitrogen removal was ammonia stripping, which converts ammonium to ammonia gas. This was ultimately rejected due to high costs. We also looked into the addition of 3 newly constructed 1.1 million gallon post-anoxic basins. This also wasn't chosen due to costs. The final alternative we looked at for nitrogen removal was the addition of 3 newly constructed pre-anoxic basins. This was found to be our best option for nitrogen removal, but ultimately was not our chosen alternative. And now Kaylee will talk about the other alternatives.
The alternatives for the phosphorus removal are for both Farmington Bay and Gilbert Bay. The total phosphorus that needs to be removed for NDSD is less than or equal to 0.1 milligrams per liter. For Farmington Bay, there is 2 alternatives, COMAG and alum and rapid sand filters. The COMAG is a newer process that not many treatment plants have started, but it can reduce total phosphorus. COMAG is tertiary ballasted sedimentation with magnetite, alum, and polymer in mixing chambers, conical clarifiers, and magnetic COMAG recovery. However, COMAG was rejected because of the complexity of operation and maintenance and expensive costs. The other alternative for Farmington Bay is alum and rapid sand filters. This alternative was tentatively chosen due to the simple operation and maintenance it required. It was also reasonable because of how economical it was with costs and total phosphorus removal. Gilbert Bay phosphorus removal also had 2 alternatives, constructed wetlands and alum addition to 1 milligram total phosphorus. The wetlands require 130 acres of engineered subsurface wetlands for sorption, plant uptake, and precipitation of nutrients. This entails an intense operation and maintenance and was rejected due to high cost and relative unreliability. The alum addition was the chosen alternative and requires 5.35 tons of alum per day to a secondary effluent into 2 tertiary clarifiers. In the alum and rapid sand filters, it only takes the effluent to 1 tertiary clarifier. Having the extra clarifier and the alum addition to 1 milligram per liter of total phosphorus adds sufficient removal of total phosphorus. Furthermore, it is a simple operation and maintenance and a low cost. However, it will require a new outfall location located up here in figure 1B and 150 foot in diameter of tertiary clarifiers. Our concept and design of the project includes a cost estimate of $28 million to achieve the 1 milligram per liter total phosphorus. The amounts of concrete, steel, pipe, and alum are included in the design. This mechanical design is a drawing Morningstar Engineering created to accurately develop the chosen alternative. Some recommendations NDSD does like to recommend is including a secondary diversion to a secondary irrigation in the months of April through October. The secondary effluent is taken to Davis-Lieber Canal Company, and it will help Gilbert Bay with its nutrient limits during the seasonal times or seasonal months between April and October. It requires a 96-inch pipe and about 1,450 horsepower pump. It will save NDSD $5 million on their chosen alternative. The acknowledgements that Morningstar Engineering would like to include is WAU, our club, Ryan Bench, our PE from Corolla Engineers, Dr. Ryan DuPont, our faculty advisor, Professor Ball, and Hydromantis Environmental Software Solutions Incorporated for providing CabDetWorks wastewater modeling software. Thank you, and goodbye.